Hi, and welcome back to the Low-Level Devel channel's Linux Distribution from Scratch series. In this video, we're going to continue on with the development of the package manager. We will load the repository information so we can get ready to start building and installing packages in future videos. So let's get started. Now to start off, I'm going to add some more variables to this structure for LLDOS package. So these initial fields we added, those are the YAML fields in the YAML of that document. Okay, so now we're going to add some temporary fields to source some data about these packages as well. First will be a Boolean if it's installed or not. Next will be the repository path, and Boolean whether it's a dependency, so that we can implement the build dependencies feature. So now to start off with, we want to set some of these values. So I need to implement this packages installed function. I'm going to put it here in the package.c. So when we install a package, we're going to put it in that user share spkm directory in an inst path. So first I'm going to set up the name of that path. Okay, so it's going to be the root being the user share spkm. So we're going to follow the same structure as the repo directory as well. Okay. So we're just going to copy that .pck over when we install something. So we're going to say if that file exists, then we'll consider it as installed. Just a simple implementation. You know, in your own, you may want to implement something more advanced than this, but we're just using file-based. So now let's move on to the next section where we're going to, in our package load function, we want to actually set that field. So when we load a package into memory, we'll call that packages installed function. Alright, setting that variable, and we'll also set the base path of the repository path of this package, just kind of convenience variable, so we don't have to keep calling this snprintf every time. Then we'll just use stirdup to copy that over. Remember, eventually we're going to need to free up all these strings we're creating, but in this initial set, I just want to get us going here. So now moving on to the next, we'll add another function in this header. Typedef struct, I mean. So we want to create a context here, so I'm going to call it spkm context. So this is going to be something we're going to pass around. So we're going to start with our root, our base for our user share spkm. We're going to have a package list of all the packages that are in the repository, and then we're going to have a package list of these packages that are actually installed, or packages to install. Okay, and let's see, what else do we need in this structure? Yeah, we can have like a current package in case we need that for something. Not sure if we'll use it or not. So let's see, we'll have these are going to be the options that we're going to pass in when we run the package manager. We can install, rebuild, we'll have a verbose logging option and a rebuild dependencies option. Okay, now let's go implement this function we're going to call, I think, load. Yeah, we'll call it package load context. So it'll take in a pointer to that context. a list of the packages that we want to install or build. So we'll call this package load all. We're going to grab that PCKM base as the root, and then this all packages list. If you remember, we created that package load all in a previous video. Now we're going to load package dependencies. So we'll pass in context and packages and false. That's going to be whether it's a dependency or not. So I'm going to take this function and create it. So package list add dependencies. So we'll take this context, which is a pointer. Take this stir list, packages, and bool is dependency. So the very first one, it's not a dependency, but any ones that get called in this recursive function will be considered dependencies. So we're just going to loop through this linked list, same as we've done before. Nope, not names, next. Okay. Now, so we're going to get the package list find. So we want to find a package in this all packages list with that name. So if it's not found, then we know something went wrong here. So we'll say invalid package and print it out. At that point we can just return false. Alright, so now if we do have the package, then we actually want to make sure we add all of its dependencies. So let's start by calling package list find ctx packages name. So we want to find the one in the name. So if it does exist in that list of packages, that means it's already installed. It's already in the it's already in the install build package list. Because some packages may depend on others and they were already added, so we don't want to keep re-adding them. So now we're going to load the package dependencies, and notice we put true for the is dependency. So fail to add dependencies for package if that fails. Now we also want to do this for the make dependencies. If you remember, we have mk deps. If we're building, then we want to do that. So let's see, I think for each of them after this, we can say if it's a rebuild, that's when we want to do this package list add dependencies. Yeah, let me just paste that. I'll cut that here and paste it in here. So remember, we only want to add the make dependencies if we're actually going to be building that. If it's just an install, we don't need to add make dependencies. So now we're going to create a new entry here. If it is a dependency and it's not installed, or rebuild dependencies is set, then we're going to say package list add ctx packages and package. So if it is a dependency and it's not installed, or we want to rebuild the dependencies, then we're going to add that to our list of things that needs to be rebuilt. So else if it's not a dependency, That means it's something the user entered in, and it's not installed, or we want to just rebuild anyway. Then we're going to add that. Otherwise, we're not going to add it at all. So now if E, we're going to set its isDep to the isDep in the function. That way we know later on if it's a dependency or if it's something user entered. So now we can return true. I think that's it for that function. So now I'm going to move on to the main, and we're going to implement the command line parameters. First I need to add some of these headers, because our initial implementation of that main function is going to go away. It's going to look more like this one, that simple package creator. If you remember, we had this doc and the args doc and the options, all that stuff. So we're going to put that same kind of thing up here. And actually I think we can just copy those from this one to start with, and we'll just edit. And I'm not going to go over what all these things mean in detail, because we kind of did that over the simple package creator before. And I'm going to assume that you've went through those videos already, so I don't have to repeat myself here. So the arguments doc is going to be package name, because you can pass package name as the argument parameters. Let me think what I want to do with these options. I know I want to keep root. Don't know that I want any of these others though. Yeah, I can just delete those. Okay, so I'm going to have an option install, which we'll use I 00, and I'll say install package. We might want to rebuild and not install. So, alright, let's just paste this a couple times. We'll have a rebuild. So R, rebuild dependencies, rebuild deps. We'll make that D. And we want a verbose option, so we have some verbose logging if we want it. I'll just change these. Rebuild package, rebuild package dependencies. And just say verbose logging. I think that should be all the parameters we want, at least for now. Again, we're keeping this simple. This is just a starting point for how you would develop your own. And let me see, remember we had this parseOpt function as well, where we parse out all the different options that the user enters. So I'm not going to explain this part in detail as well. I'm just going to kind of breeze through it. So I'm going to speed this up again and just kind of type this really fast. Alright, so we're getting the context from that input. For switching each of these keys, we'll have a R for root. So we're going to check the installed flag, rebuild deps flag, verbose, and each of these arguments we're going to use that stir list append and append it to our package names, and then return argp error unknown if it's not found. And we're also going to go over here and copy this static struct here, argp. So now we can go back to normal speed. Let's see, trying to think what we're going to need to keep here. First of all, actually we want to create our context. SPKM context. Initializing that all to 0. Okay, so now I'll start loading that. And there was a function. Actually, first, yeah, let's parse the arguments. argp, argc, argv00, and the context. And that should be all good. So now if context root isn't set, then we're going to set it to / by default. And we're also going to read from the option, the environment option, spkm root. If that is set, then we're going to set the context root to that. Okay, that should be all we need for that check. Now we can go through and actually, actually we need to make sure that they passed in at least one package, because if they didn't, then there's no reason to run. So we need at least one package. And we'll use fprintf stdr, package required. Okay. So now we're going to set up a base location. We'll say it's going to be /user share spkm ctx.root. So that's the base for the simple package manager. Use stirdup. Alright, so now we're going to use some of this verbose logging. First we want to load the context actually. It's not finding the context function. Let's see, package names. So now we're going to loop through this linked list of packages. Any of the packages we want to install essentially. So starting at the head, while e is not null, and eNext. You can actually create a macro for that. It makes it a little easier, but I want to make this readable. So we'll say if it's verbose, then we're going to printf just the package and its name. Okay, package names. Alright, package load context. Let me make sure I've implemented that. Yeah, there it is. It's in the package list. So I just need to put this in our header file so we can see it. We'll put it in package.h. Okay, so now moving on, not sure if we want to save any of this down here or not. Probably not. Alright, actually I'm going to loop through this package list again. So that first one was just for our verbose logging. Now I'm going to run through each of those, and actually this is where we would put our code to do the actual building and installing, which I'm just going to create temporary functions for now as placeholders until we implement them. So I'll say if not package build, that's going to be a new function that we're going to create. So it's going to take in, I think, the root, so context root, and the package object. And so in this case, if it fails to build, then we'll fprintf stdr and say build failed. And we'll just return -1. So after we would build the package, then we want to see ctx. So if we passed in the option install, or if package is a dependency, then we pretty much have to install it. And let's see, e package installed. So, and it's not installed because we won't have to reinstall it. So we're going to call this package install command. That'll take in a context and a package. And let's see, if that fails, we'll again just fprintf stdir install failure. Then we'll return -1. So now otherwise, let's just say print out package installed, and then we can put the name of the package, I suppose. Yeah, e package name. And yeah, I'm not going to need any of this. Just delete all that. I think that's pretty much it. So we'll create the shell for these functions for now. They'll actually be implemented in their own files, but for now I'm just going to kind of add some simple implementations that do pretty much nothing. So let's say package build. So it'll take in a root and a package object. I'll just put it up here for now. So build package. Or actually, wait a minute, that was package build, right? Package build, yep. So bool package build takes in a root and the package object, oh, LLDOS package pointer. So pretty much return true. Maybe I'll add some printing. We'll say build skipping for now. Yeah. And then the same thing for our package install. It's going to take, oh yeah, SPKM context. Package, another to do, printf, let's say install skipping for now, return true. Let's try building this, see what happens. Go to source, SPKM, clear, and make. Duplicate case value. Okay, R is already used for roots, that's right. Just some of you probably picked up on this already. I should make that maybe just B for build. Alright. So B and B. There we go. So now if we run it, package required, of course. Alright, so let's say we want the root going to be this path. And build environment, build root. So that's going to be our root that we're using. Then we want the options dash B for build and I for install. We'll say glibc invalid package. Why is it saying invalid package? Let me add that verbose logging. Yeah, it didn't even load any package. Oh, I think we need to copy our repository over to that build root. So we'll need to take that user share SPKM. Yeah, because we are loading the context. So let's make that directory if it doesn't exist. Let's see. ls user share SPKM. let's make that directory. User share spkm. And inside spkm there's also going to be a couple of different folders. We'll have the inst folder, if you remember. Oh, we need call sudo. We'll have build eventually, and a repo folder for the repository files. Maybe that's enough for now. Let's just try running that again. Or actually, we're going to want to copy this repo folder that has our files in it and copy it over to here. So let's see, let's try this again. Hey, there you go, package glibc, build skipping for now. Looks like we need a /n somewhere. Yeah, there you go. So I have a /n there. And these are our files. We can maybe add more to the command line. So let's see, let's make sure they were all copied. Yeah, glibc, zlibstd, shadow. Alright, so let's say if we do bzip2. Yep, it found it, and it's saying, let's see, let's remake. Okay, there we go. So we'll say bzip2 and glibc and shadow. There you go. All three of them found. And we should also test what happens if we add something like ASDF doesn't exist. And there you go, invalid package. So showed these ones got actually installed, and then we say invalid package for the one it didn't find. Probably not the best option, but for now, but that's a good start at least. So I think we'll end this video here, and then the next video we'll start implementing the build option, which is actually going to use several functions we've already created in other videos in a different series called the Linux Systems Programming series. So I'll just kind of point to those videos where needed. So hopefully you learned something on this video as well, and if you did and you enjoyed it, please share it, like, comment, subscribe, and all that, and thanks for watching.